சிமுலேஷன் ரிசல்ட்ஸ் அண்ட் டிஸ்கஷன்ஸு. இதுக்கு முன்னாடி நம்ம மேத்தமெட்டிக்கலாக டிஸ்கிரிப்ஷன் பார்த்தோம். இப்போ சிமுலேஷன் ரிசல்ட்ஸ் அண்ட் டிஸ்கஷன்ஸு. Through the numerical simulations in various constellation scenarios, this first section verifies the proposed proportion and properties. Then the key network metrics of 3ASL are evaluated and compared to 4ASL topology. Both the user density distribution and multiple gateways are considered, and the effects are caused by pruned ISLs are further discussed. Verification of the proportion and properties. To verify the proposed routing proportions and properties, the Monte Carlo simulation method is adopted. Scenarios are established with different NP and MP ranging from 4 to 100. In each scenario, all the node pairs are traversed and examined. When NP-MP greater than 1000 up to 1 cross 1 10 power 6 node pairs are randomly selected for examination. The Dijkstra's algorithm is adopted to generate the shortest path between the node pairs as a benchmark for verification. Then the routing metrics of 3ASL topology, including hop count, network diameter, and AID, are compared to the network's AID are compared to the theoretical formulation. Result indicate that there is no error, confirming the accuracy of the proportions and properties. Further, when the path diversity is examined, slight deviations may occur in the 3ASL torus topology because the torus topology enables the path in the opposite direction. Extra path may occur, but if the paths are limited within the mesh topology, then this issue is avoided. Note that the related formula for 4ASL topology have been 4ASL topology have been well studied and examined and are not further discussed in this article. Network performance comparison between the 3ASL and 4ASL topologies. To investigate the network performance affected by pruned ISLs, simulations are evaluated with the two ISL topologies in various constellations based on the typical mega constellation configuration. 53 degree at 550 km, NP is equal to where NP is equal to 72, MP is equal to 22. 6 variant constellations are generated and tested. The 12 cross 22, 24 cross 22 and 36 cross 22 configurations are with 1 by 6, 1 by 3 and 1 by 2 of the total satellite of 72 cross 22 case, 36 cross 44 and 24 cross 66 are the other two versions of the 1584 satellite configuration. Hop count comparison by selecting a central satellite and calculating its hop distance to all other satellites. The maximum and average intersatellite hop distance are obtained. Both the two metrics exhibit similar trends. Maximum hop distance or network diameter grows linearly with the constellation scales, while in the 3ASL topology, the maximum hop distance grows faster. In addition, more orbital planes result in a higher maximum hop distance. In the 72 cross 22 constellation, the 3ASL topology may cause up to 35 additional hop compared to 4ASL case. This is due to the large interplane hops, which also necessitate many extra interplane hops. When the total satellite number is fixed and orbital planes are reduced, the metric can be reduced to the same as in the 4ASL case. The features have well within the formulated result. As shown in the figure 9, the average hop distance exhibits a similar trend to the maximum hope distance, while its value is approximately half than the maximum value. The future is consistent with those regular and uniform network topologies. Similarly, the average hop distance can be greatly reduced when more satellites are distributed in few orbit planes, and later 12 all indicate that the increase of NP instead of MP has more remarkable impact on the network performance. The, the these figures represents the cumulative distribution function of the hop count over the network. For 72 cross 22 and 24 cross 66 constellations respectively, it is evident that with an increased number of orbital planes, the required hop count for 3-acyl topology rises and the hop count distribution becomes more uniform. However, when the constellation configuration is adjusted to 24 cross 66, when the hop count distribution converges significantly because the hop count distribution converges significantly because the errors can be avoided. In terms of average hop distance, the metric increases by 3.21% even though 25% of ISLs are saved. Since ISL becomes shorter, when the constellation is dense, the physical ISL distance as well as the link delay may not vary as noticeably as the hop count. The diagram 12 diagram illustrates figure number 12 illustrates the corresponding intersatellite delay in the different scenarios. We can observe the delay remains relatively flat as the constellation scale increases. The total path length can be stable even if more intermediate satellites and hopes are added. However, the delay also experiences a significant increase in 3-acyl case when the constellation has more planes. In the 72 plus 22 constellations, the delay has increased by more than double, but as long as NP is less than MP, the impact of pruned ISL become much weaker. By seeing the result of 36 cross 44 and 24 cross 66 cases. Thank you.